Good morning and what's up guys. In fact, in the last videos I just shared something from the pharmaceutical calculations, and in today's video I'm also going to do the same thing, but today I'm going to talk about the alligation method. So alligation method, I think you are not from the ABC level, so you know what alligation means. Alligation, in fact, this is a arithmetic method of calculating different issues related to the concentration and volume of mixing solutions. So the basic is that you will have certain solutions given with certain given concentration, and you also have a final solution which is already mixed and also have a certain concentrations. Maybe you will ask to calculate the concentration, sorry, not the concentration, maybe you are asked to calculate the proportions of the elements used in the solutions. Say for example, if I talk about you have been asked to mix 40% alcohol with 30% alcohol to make a solution of having concentration 25%. Now you have been asked what should be the ratio of mixing two solutions. So this type of math we can solve by the alligation method. Particularly alligation method is having two different categories. One is alligation alternate and another is alligation medial. So if we have any given solutions with given concentrations and we need to calculate the ratio of mixing equipments or mixing elements, then we need to use the alligation alternate. So basically in this class we are going to talk about that alligation alternate method. So if you see these things here, these are actually certain outlines. I have already kept it here just for your reference, and I will discuss individual things later on. In fact, in this class, obviously. So let's start with the alligation alternate. So first of all, just have a math here. In what proportion should alcohols of 95% and 50% strength be mixed to make 70% alcohol? So the question is 95% alcohol and 50% of alcohol. These two things are mixed. 95% alcohol and 50% alcohol both are mixed together, and the final solution, I mean the result, was 70% alcohol. So they have been mixed in such a way the concentration of the final volume is 70%. So the question is, what is the ratio of mixing these two things? I mean, how much of the 95% alcohol and how much from the 50% alcohol is to be mixed together so that the concentration of the final volume will be 70%. So this kind of mathematical problem you can solve using the alligation alternate. So the thing is that you just carefully observe there are a couple of things. Basically these all are concentrations, and obviously this is the desired concentrations. This is the desired concentrations, and rest of the concentrations are actually concentration of the mixing elements. So if we see here three concentrations, say for example if we talk about this one and this one, this is A, B, and the desired concentration, say for example it is C. So how we have to solve this problem? First of all, we have to write the higher concentration here, like 95%. We don't need to put the percentage here, just to make the calculation easy. So first of all we have to write the higher concentration. In the bottom we have to write the lower concentration. In between this place, this is gonna be a kind of a tic-tac-toe diagram. So this is the highest concentration, just giving you a note, higher concentration, and the lower concentration, and at this place we have to write the desired concentration, which is 70%. Now we have to do a kind of a cross math, which is already given here. So this is actually following the rule from method 1, this one I am talking about. So what does these arrows mean? So these arrows means we need to perform a calculations between 95 and 70, and we have to put that number here, and another calculations in between 50 and 70, and the calculations result will be here. Like so 95% and 70, we have to find out the difference. So 95 minus 70 becomes 5, then 2, 25. And what about this one? The difference is 20. So here you are doing 95 minus 70, and here you are doing 70 minus 50. So these are the outcomes. So 20 and 25 is the outcomes here. Now the thing is that it represents that 95% alcohol, 20 parts, and 50% alcohol, 25 parts. So if anybody talk about what is the ratio, say in these questions they asked what proportion. So if we talk about the proportions are 20 to 25. This is the basic proportions. Now we can also simplify it like by if we divide it by 5. So 5 into 4 equals 20, 5 into 5 equals 25. So it becomes 4:5. So this is basically the proportions you are deriving from this kind of cross calculation or tic-tac-toe method. So I think you have already got the answer. 95% alcohol is mixed with 50% alcohol to make a alcohol solution of 70%. So what is the mixing ratio of these two alcohol solutions? So the answer is 4:5. So if 4 ml of this one is introduced, 5 ml of this one is to be introduced into the solution. So only then the concentration will be 70%. So I think method 1 is covered. Now you will find certain cases where 3 solutions are there. So 3 solutions are there that can be solved by these two methods, and if there is 4 elements, these are the method where you can do the solve math. So let's do another example with the method 1. So this is another math. So what proportion should 20% benzocaine ointment be mixed with an ointment base to produce 2.5% benzocaine? So now they're telling 20% benzocaine ointment. 20% benzocaine ointment is to be mixed with an ointment base. Ointment base is to be mixed with something so that the final concentration become 2.5%. So it's very interesting. Here they are actually mixing one active ingredient to a base so that they have a final substance with a concentration of 2.5. So that's quite interesting, because here they have 20% of benzocaine solutions and 0% of benzocaine. So if it is just a base, so it means it doesn't have any active ingredients, so the concentration of active ingredient over there is just 0. So now we have the higher concentration here and the lower concentration here, and we have a desired concentration here. So we can do it simply like we can remove the percent for calculations. So what will be the outcomes here? 20, 0, 2.5. This is how we have to do it. So it comes like, so 20 minus 2.5, it becomes 17, 17.5, am I right? Yeah, 17.5. And what about this one? This is just 2.5. So they have asked what proportion. So already we have got the answer. The proportion is 2.5 to 17.5. Now I think we can simplify it in a better way. Like we can also remove the point sign from both sides because they are on the same gap. So it is 25 to 175. I think we can divide it with 5 again. So 5 multiplied by 5 equals 25. Then 5 3 15, so 2 5 25, then 5 1:7, I think. Yeah, 1:7 probably. Let me check. Yes, yeah, perfect. So from 2.5 to 17.5 we derived 1:7. That is the final ratio of these two things. So if I just mix one part of this one, we have to mix 7 part of the base. So for each part of 20% benzocaine, we have to mix 7 part of the base. Only then the final concentration of the benzocaine ointment will be 2.5%. So just this method we are using to calculate the proportions. Now let's have another examples. Let me see if anything is there for us or not. Yeah, a new one. How many milliliters of each of a 2% WBV solution and a 7% WBV solution should be used in preparing 1 gallon of 3.5% W/V solution? So it's very interesting. We can write it 2% W/V solution, 7% W/V solution of certain thing. They are mixed together, and the final volume is 3.5% W/V solution. And now they asked if we want to make 1 gallon of 3.5% W/V solution, then how much of each one is to be mixed together. So other than ratio, we can also calculate the ratio from here. So now they are asking not only the ratio, they are actually asking how many of each of the items will be mixed together to produce 1 gallon of 3.5% W/V solution. Okay, so let's begin with our normal process. So first of all, higher concentration, lower concentration. So it should be 7 and 2 here. The desired concentration 3.5. So outcomes here like 3.5 again. I'm just doing the cross here. So it becomes 1.5. So ratio is 1.5 to 3.5, I think. Yeah. So we can omit these portions. Now we can simplify it like 5 into 3 equals 15, 5, 7. So 3:7 probably. Yeah. So 3:7. So what does it mean? It means I think we should make it simple, like 3:7. Remember, 3:7. So it becomes 3:7. So 3:7 or 3:7 here means if the total volume is 10, total, if there is total 10 part, 3 part will be this solution and 7 part will be this solution. Within the 10 part of solution, 3 part will be from the 7% solution and 7 part will be from the 2% solution. That is the basic funda we need to understand now. We have to understand that we can have a total things from here as well. So now they are asking if the solution is 1 gallon. So what is 1 gallon? 1 gallon means 3785 probably. Yeah, 3785 ml. 3785 ml. So now they are asking how many of these two things will be mixed together to make 3785 ml. So now we know the ratio. When the solution, final solution volume is 10, the 7% solution is 3. So they are asking when the final solution is 3785, what should be this one? So we can do the math like we don't know what is the amount of this one. So like if it is, let's do a ratio thing. 3/10 equals 3/10 equals x by 3785. Just doing a ratio, proportional equations. From this part, it becomes like 10/3 equals 3785 by, okay, fine. So here we can have a result like x equals 1135. I'm just not doing the calculations to save the time as well as the space as well as the ink of this pen. So from these calculations we can have the value of x here. So within this 3785 ml 1135, this amount is actually the 7% item, 7%, yeah, and the rest is actually the the 2% solution. So you can also do it by two method. I mean 3785 minus this one, that can be done, or we can also do the things in similar way, like here it will be 7 by 10 and it will be like y by something, and then y will be like how much, 2650, it will be like 2650. So ultimately 2650, let me write here 2650, and another one is 1135. So 1135 ml, 2650 ml mixed together, the final volume is 3785 and the final concentration is 3.5. That is the basic thing. So other than ratio, you are just also calculating the final volume from this proportional calculations. So this is kind of an addition. Let's go for let me see if any single issues are there. So another example, how many grams of 2.5% hydrocortisone cream should be mixed with 360 gram of 2.5% cream to make a 1% hydrocortisone cream? It's very interesting. Now they are, trying to do trick with us. So 2.5% hydrocortisone cream mixed with 0.25% hydrocortisone cream, final concentration is 1%. Now they are asking the volume of this one, the amount of this one is 360. Now they are asking what is the amount of this one. They didn't ask anything or gave anything related to the amount of the final solutions, but they gave the quantity of one part so that we can calculate the quantity or amount of the other part. So how we can do this? So same way, higher concentration, lower concentration, 2.5, 0.25, desired concentration 1. So if we do the math thing here, 1 minus 0.25, it becomes 0.75 here, and 2.5 minus 1, it becomes 1.5, yeah, 1.5. So the ratio is 0.75 is to 1.5. Okay, so if we remove this one, we have to add a 0 here just to make it simple. So the ratio is 75 to 150. So now we can, we can make it simplified. 75, if we just multiply, okay, 75 divided by 75 equals 1, 75 divided by this one, 2, I think, 1 is to 2 probably, yeah, yes, 1 is to 2. So the ratio finally we got 1 is to 2. So now see one thing, so this one is x. So if we do a ratio x by 360, it will become like 1 by 2. because we got 1 here and 2 here as part of ratio. So from this point we can calculate x equals 360 by 2, I mean 180. Yes, x equals 180. So now we are doing the ratio just to calculate the content of one item, not the we don't given any concentration or amount of the final thing. So we are doing the math in a different way, but basic thing is this one, alligation alternate, is same everywhere. Now let's do another math. It's already solved. How many grams of zinc oxide should be added to 3200 gram of 5% zinc oxide ointment to prepare an ointment containing 20% zinc oxide? Okay, how many gram of zinc oxide? So they have given us two things. One is zinc oxide and another is 5% zinc oxide. So when we are talking about 5% zinc oxide, it means the strength is 5%. But when we talk about zinc oxide, simply it means 100% zinc oxide. So they have given two things. One is 100% zinc oxide, ZnO. In fact, I am just jotting it down. And another is 5% zinc oxide. And the concentration of the final volume is 20%. They have given the amount of this portion. Yeah. 3200. Now they are asking what will be the amount of this one. So let's have a math here in the same way. So 100, just consider the persons are not there, so 100 minus 20, it becomes like 80, and 20 minus 5 becomes 15. So we can do a ratio here, 15:80. So start with 5, so 5, 3, 5, 16. So it becomes 3:16, the ratio here. So we can do the math same way, consider it as an x. So x by 3200 equals 3/16. So x become, so value of x is simply 600. Yeah. So 600 gram of raw 600 gram of raw zinc oxide, I mean 100% zinc oxide, is added with 3200 gram of 5% zinc oxide, and the final concentration is 20%. Now if anybody asks you about the final volume, definitely it will be 3200 plus 600, I mean 3800. That will be the answer in that case. So I think the alligation method based on mixing two elements is already solved. We don't have anything much here. I think maybe in another day we can start with mixing this way. I mean they will have three elements together to be mixed, and there will be a final solution. Another day we can also try adding 4 elements. So I'm not doing it now because it will take a lot of time. So I think it's enough for today. In the next class we'll try to cover these things up. I mean adding 3 elements or mixing 3 elements or mixing 4 elements. I mean in both cases the calculation can be done in different way, but there are some rules which we will discuss in that class. So till then, take care, goodbye, hope to see you in the next video.